Hello everyone. So in today's video I'm going to go over this paper titled Detecting the Hate Code on Social Media by Rajul Magu, Kshitij Joshi and Jay Bulwo from the University of Rochester. So as you can see this paper is from 2017. So already abstract. Social media has become an indispensable part of the everyday lives of millions of people around the world. It provides a platform for expressing opinions and beliefs communicated to a mass audience. However, this ease with which people can express themselves has also allowed for the large scale spread of propaganda and hate speech. To prevent violating the abuse policies of social media platform and also to avoid detection by automatic systems like Google's conversation AI, racists have begun to use a code, a movement termed Operation Google. Alright, this is the first time I'm hearing of this. This involves substituting references to communities by benign words that seem out of context in hate-filled post or tweet. For example, users have used the words Googles and Bings to represent the African American and Asian communities respectively. By generating the list of users who post such content, we move a step forward from classifying tweets by allowing us to study the usage pattern of these concentrated set of users. So I guess at this point of time, Google was using some sort of AI to detect, which was unable to capture these nuances. Even at this point of time, I'm pretty sure there are lots of cases where AIs fails, especially things like implicit hate speech, which have been in the talk recently. Alright, so the introduction. Uh, okay, also this paper is from AAAI. Introduction. Internet usage has grown tremendously over time from a figure of 52% of the American population that used the internet in 2000. The percentage of users grew to 84% in a span of 15 years. Within the time frame, we witnessed the rise of social media, a path-breaking socio-technological concept that changed the way people exchanged ideas and broadcast opinions. Social media has seen a parallel jump in popularity, with over 65% of Americans using social media websites in 2015 as opposed to 7% in 2005. With this increase in the user base has produced a world while this increase in the user base has produced a world that is more connected than ever before, it has also had severe negative implications that need to be accounted for. One of the most prominent ones is the ascent of online hate speech. While hate speech has been around for a long time, the ease of access to reaching and influencing the masses has been augmented through social media. The situation at present is alarming. A 2016 report analyzing anti-Semitic content on social media exposed the dismal performance of certain social media websites such as Twitter and YouTube with regards to removal of content. Twitter removed only about 22% anti-Semitic content over a 10-month period. As John Weissman of the New York Times puts it, Twitter in particular has become a cesspit of hate. So you can see that 22% is like a very low number for if say you have 1,000 tweets, only 220 of them are getting removed on average, and uh, that means around 780 tweets still persist on the server. And this is a 2016 report. Now techniques have gotten much better both for capturing such tweets, but also the people who are propagating such hate have become smarter and are using more nuanced methods. Alright. To compound the issue, a new evasive technique to avoid detection of hate speech has emerged to circumvent violating the abusive behavior policies of social media websites such as Twitter. Such users have now begun to adopt a code, a list of mappings between the names of intended target communities and seemingly innocuous, unrelated terms. The idea is to replace references to these communities in hate posts by their representative codes. So these are some commonly used code words. So you can see these examples. I won't be reading them out as they are pretty offensive. Also, at any moment, if you feel that you're not comfortable reading this paper, I'll highly recommend just leave this video because I guess this would get even darker as we go down. In this paper, we first introduce a mechanism to identify instances of such coded hate content. Because of the prominence of this phenomenon on Twitter, we show all of our experiment is carried out on tweets. We show that we are largely successful in separating the tweets which use the code words in the intended racist content from those that use the words in their regular sense. Furthermore, we create a system that extracts a set of users who frequently use the code to enable us to study the usage patterns. So, all in all, they're doing three pretty interesting things. They're uh, separating out like the code, the tweets which are actually using the code words from tweets which are using the words in the usual sense. They're also creating a system with which they are able to create like tag users who are using these coded words, and then they're studying their patterns as well. So related works. Researchers have in the past studied negative sentiment on social media. Work has been done on building classifiers that can identify content that is hateful and antagonistic in nature. Additionally, techniques have at times involved building a hate lexicon to solve the problem. However, most of these projects focus on content that is openly hateful and not disguised to evade detection. Although related, our endeavor and its novelty is geared more towards finding such instances that seek to fool the system. Alright. So the dataset, we use the Jefferson Henrik script, a web scraper, to collect a total of over a million tweets for a time frame of around a month, starting 23rd September 2016, when reportedly an incident of the first usage of hate code words was first observed, till 18th October 2016, a week after the US presidential elections, for all the known hate code word described in Table 1. Alright, so we ran the script each time with a different code word to pull Twitter data specific to that code. Finally, we extracted about a quarter of a million unique English tweets to form the set that we worked with. Alright, so the methodologies for detecting the hate. So the preliminary analysis. We ran some preliminary experiments to better understand the data before we carried out the main experiment. There were some interesting observations that were noted. First, by randomly annotating tweets in our database, we extracted 1048 tweets which we could label hateful and 951 tweets which could be labeled non-hateful. Using this set, we calculate the Pearson correlation coefficient between the occurrence of every term present in the set of tweets and the class label. Note that terms have been lemmatized. The top 10 correlated terms are shown in table 2. Alright, so these are the top 10 correlated terms with the hateful tweets. An analysis of the top 10 terms provides insight into the common themes regarding the hate code. The hashtag MAGA, which refers to the slogan Make America Great Again, used during the election. The hashtag MAWA for white supremacy is a reference to white nationalism. Additionally, the term white also pops up very high in the list. A lot of these terms are common phrases and terminology used by the group of people who identify themselves as alternative right or the alt-right. The group shares a set of ideologies in the far right of the American political spectrum, calling for a new, radical conservative movement. The group has been criticized for delving in racism, anti-Semitism, and homophobia, with frequent parallels being drawn with the white supremacist movement. Not surprisingly, therefore, one of the top terms in the list coming in at second place is the hashtag alt-right. One alarming observation is the occurrence of the term gas. The term gas has been used in these contexts, which is like calling for violence towards the Jewish community. It is particularly this unchecked, uh, abject display of hatred and calls for violence that we hope to capture through our system. The most interesting of these, however, is the use of the triple parenthesis or the echo symbol. Uh, I can't. Okay, so this is what they call in the echo symbol as well. The triple parenthesis is used and the triple parenthesis used an anti-Semitic device on Twitter to distinctly mark out the Jewish community or individual Jews, often as a mean to bully them. The typical practice is to surround a person's name by the brackets on either side. We noted that significant number of people who use the code word Skype often also made the use of the triple parenthesis. Alright. They've been successfully able to get some uh, critical information on how or what words are majorly involved with hateful content and how are they like masking their tweets from the algorithm. Next, we ran the a priori algorithm for frequently item set minimizing on a randomly selected set of tweets that we identified as hateful. Some of the primary frequent patterns that emerged were all of these. Insights noting are the Jewish community is particularly targeted. This can be seen from the fact that many of the frequent items said contain the word Skype, a reference to Jews. For example, the phrase okay. A large number of tweets contained multiple code words together. This reflected the fact that aggressor displayed blanket hate towards multiple communities as opposed to targeted preferences. To this end, the pairwise co-occurrence value as percentage as the total extracted hateful of the total extracted hateful tweet can be observed in Figure 1. It is noteworthy that the value for uh, trumps these two words, Google Skype, trumps other pairwise co-occurrence by a sizable margin, standing at 9.6% of the total tweets. From a temporal perspective, we noted a sharp spike in the use of code words in the first week of October, peaking around the fourth week of October. This coincided with the second presidential debate. So, where's figure 1? Right, so you can see these are the more frequently occurring ones. So, what were these codes for? Google and Skype. Okay, so blanket here towards the African American and Jewish community is like the most in the tweets that they were able to collect. So identifying aggressors. An important aspect of our approach consisted of training a classifier to identify hate tweets which included usage of coded words. Our initial step involved annotating a sizable number of tweets to be used as a training set. We randomly picked tweets out of the tweet base and continued annotating till we had a class balance between the class of benign and hateful tweets. So this is important because then uh, if you don't do this, then you have this additional bias of the class imbalance. So if you have say only 10% non-hateful and 90% hateful tweets, then the model also might become skewed. Moreover, we only marked a tweet as hateful if it had a code word for a community and it appeared as if the community was being targeted. All other cases we marked as benign, even those cases in which a code word had been used but not to harshly mock or call for attack against but to protect or defend the community. Alright. So this makes quite a lot of sense because you don't want to have tweets which are actually helping people out marked as hateful. Clearly, communities are being mocked here. It is apparent if one replaces Skypes with Jewish and Googles with the Afro American community, and hence it has been encoded as hate speech. So, this is an example of hate speech. For the following examples, in the first example, Skype is indeed used as a benign verb which is meant to indicate the Skype calling. In the second, though, the Twitter at I evidently did not mean those words to be benign but communities, but as the person is trying to warn a potential aggressor, it was not marked as a positive case. So these make sense. Alright, so we'll have a look at the flowchart once it pops up in the text. Since we wanted to train the classifier to be able to categorize a record of unstructured data, that is an English sentence, we followed a bag of words model to represent a sentence in the training set with Boolean feature vector, where features are the most popular words in the corpora or training data. As part of the pre-processing of the tweet, they were before they could be converted to feature vectors, we lemmatized every token in a tweet and then removed punctuation, stop words, infrequent words from it. We built a support vector machine classifier to be able to segregate the hateful tweets. The next step involved running our classifier for a test set which was created by randomly selecting 10% of the codes in the tweet base. These sentences were then pre-processed and converted to feature vectors in the same manner as the ones in the training set. We ran the classifier on this sample set to generate a list of tweets which were marked as hateful by the program. The final step involved finding the handles of all tweets tagged as hateful and the number of hate tweets which have been tagged from these handles. Handles having frequencies that cross a threshold were considered qualified to be put in a list of potential aggressors. Right, so you don't really want to like tag every single account which even has one tweet because then you'll be in a mess with hundreds of thousands if not tens of thousands of accounts, and lots of them might just be dummy accounts, but accounts which are posting more regularly or have more hateful tweets are more likely to be real accounts of people. So I guess this part was pretty clear. They explained how they create like selected the tweets. For they trained the model on tweets which were lemmatized and then stop words removed, punctuation removed, infrequent words removed, and then they ran it on a randomly selected 10% set of the tweet base. So the experimental results, we use the annotated 1999 tweets, each containing single or multiple use of code words with 951 non-hateful tweets and 1048 hateful tweets as our training set. The annotated tweets were fed to a SVM classifier with a linear kernel and using tenfold cross-validation to learn to distinguish between the two. The accuracy was 79.43 with a precision of 0.795 and a recall of 0.794. More performance measures can be observed in Table 3. Furthermore, Table 4 showcases the confusion matrix. Alright. So you can have a look at these scores as well. We ran the classifier on 23,401 tweets, which were extra English language tweets that had further been extracted from 50,000 randomly selected tweets, resulting in the generation of handles that the classifier identified as being as having posted tweets that use a racist code, along with the count of the total number of corresponding hateful tweets that were associated with the user. We found that for a given sample size, the threshold frequency of 4 was optimal in capturing a significant number of aggressors. So, if an account had uh, at least 4 tweets, then it was marked as a potential aggressor. So conclusions: we were successfully able to project the hate content problem on Twitter into a classification problem that we solved to an extent using SVM. Additionally, apart from the system's ability to predict for a given tweet whether it is hateful or not, the system also generates a list of users who frequently post such content. This provides us with an interesting insight into the usage patterns of hate mongers in terms of how they express bigotry, racism, and propaganda. A few different paths of possible research emerge. First and foremost is the line of study we plan to undertake in the immediate future with regard to this project, which is to create a process to automatically identify new code words. This would require a large time frame because usage patterns change over a long period of duration, which imply a slow gradual adoption of new code words in the lexicon. A study conducted after the generation of the list of aggressors indicated no use of new terminology. Another possible direction is to identify whether there exists some kind of network structure between the users, that is if the users are connected, follow the same personalities, etc. The hypothesis is there indeed exists some kind of nexus, although this needs to be verified. Community detection in this manner would provide an extra boost to identify more aggressors and thereby their usage patterns. We noted how there was a sudden spurge in the use of code words during the second debate. More work can be carried out to determine if the rate of generation of such coded messages peaks during turmoil, such as political unrest or terror attacks. As an extension to the above, research can also be done to check if there are certain regions with abnormal, consistently high uses of the code lexicon. And then they have the references. So overall, I must say this was a great paper. They explained the rationale pretty well. They explained the results pretty well, and I'm now pretty interested to go and check if the next version did come out and have a look at that as well. So thank you guys for tuning in. Hope to see you again next time as well.